Hello everyone, welcome to another one of my PowerBox series of videos. Slight change of tune for this video. Instead of looking at a transmitter screen, we're going to be looking at a PowerBox Mercury SR2. Little handy device here, quite a compact little unit, 40 amps peak. It basically provides us with 16 PWM outputs. It allows us to match servos. It allows us to connect the gyro to it. So using the little tiny iGyro sat, it forms the basis of a stabilized receiver setup. And its main function is power and distribution and the management of that. So you'll notice at the bottom here, we've got 16 servo outputs. We have 2 battery inputs. And basically these 2 battery inputs are fully isolated. Same goes for the servo ports. So if you get a short circuit on one of these servo connectors, it doesn't take out the whole avionics. It basically it isolates all the other servos from the dodgy one. We also have a couple of servo headers up here. We have 4 servo headers. So in this video, we're going to be concentrating on this input here, these 4 little inputs and outputs. And the reason being is this is like an introductory video to these devices. So the Mercury SR2 is very similar in function and connection to the Competition SR2 and the Royal SR2. So the Competition SR2 and the Royal SR2 are the big brothers to this little guy. This is the smallest unit in that family, if you like. Again, pretty tiny little unit. It's not very big. And like I said, it's 40 amps, so you know, it can handle any load that we tend to use on sort of medium to large aircraft without going crazy and going into giant scale, where typically you'd use probably like a Royal or a Competition SR2. Okay, let's have a look at a little intro video. Oh, actually, before I go on, if you hear any background noise, it's probably due to the rain. I'm filming in my garage and it's wet and windy outside, so if I get a heavy shower, you might just hear some rain on the shed roof. Okay, I'll just move the Mercury over to the side. I've actually got a drawing which I've printed out on an A3 piece of paper, just so it makes it easier a little bit to point out some of the features. So like I said, this is going to be like an introductory video, so there'll be a few more videos to follow, and eventually I'll be delving into some of the unique features of these units. Okay, let's start off with the Telly and data port. So like I said, there's actually 4 servo headers here on the unit, and the bottom one is the telemetry and data, or Telly and data header. What do we use it for? It's actually a dual function header. So in one mode it has this special Telly feature or telemetry feature. However, a lot of people get it confused with its main telemetry function for lots of radio systems, but it really is only used for multiplex and Graupner. So with PowerBox, Jetty and Futaba, JR and Spectrum, the telemetry is actually output on this RX1 line here. However, for multiplex and Graupner, they require this Telly output to be connected to their receivers as well. So just be aware, if you're using a multiplex or Graupner setup, you need to be aware of this Telly port here, and that must be connected to your receivers. Okay, it's also got a dual function where the second function is this data connection. So what that is basically if you run the PowerBox terminal program and you want to say update the firmware on the actual Mercury or your Competition or the Royal, use a little USB interface. I've just got pictured here. So that's the little PowerBox USB interface, and that plugs into a Windows PC. You can run the terminal program, and basically you connect it to this Telly data port line here. So once you connect it to there, the unit automatically switches the function of this header to a USB PC function basically, and you don't need to do anything else. If you look at the instruction manual for the Mercury, it talks about going into the menus of the Mercury on its control screen, little OLED screen, and activating the PC interface. Well, you don't have to do this anymore. The current firmware basically allows the unit to auto detect this interface adapter once it's plugged in. So basically just plug it in, fire up terminal in Windows, and away you go. Fairly easy, nothing too complicated there. I'll just remove that out of the picture. Then we have our two RX ports. We've got an RX2 and an RX1. So the units, again, same as the competition and the Royal SR2s. The Mercury also features dual redundant receiver use, and I'll explain these a little bit in a little bit further detail in a second. However, I want to move up to the fast track port to start with. So the fast track port is our first port, and that's a high-speed port, high-speed data port, and its real use is for the iGyro. So I've got a little iGyro here, so a little iGyro sat, I should say. So this guy here is just a gyro. All the gyro software is actually inside the Mercury. So this is just really a simple sensor. Or when I say simple, it's not as simple as that, but it's just basically a gyro sensor. It doesn't really have a lot of extra electronics or processing on it. It just spits out data to the Mercury. And this is why you need to connect it to fast track. The iGyro sat will only work on a fast track connection. It must be connected to fast track. So just basically plug your sensor into here. Oh, actually, while I talk about plugging in, you notice on the unit it doesn't really tell you which one's a signal line. However, if you take a close look at the cutout, you'll see a little curved section up the top here and a more of a flat sort of cutout section at the bottom, which indicates the servo header only really is meant to fit in one way. And if you look at this servo header here, you'll notice the signal lead, or the white lead, actually faces towards the middle of the unit. So the signal connection's actually on this row of pins here, not the outer row. So just be aware of that, because it's not indicated on the unit as such, and some people inadvertently connect their pins, or basically their servo plug in around the wrong way, and then complain it doesn't work, etc, etc. You won't hurt the unit, however the sensor or the receivers won't work properly. So again, just remember the actual signal line is on the inside face, and that applies to all of these headers here, so whether it's a receiver or iGyro sat connection. Okay, so remember, iGyro sat has to be connected to fast track. It can't be plugged in anywhere else. You've got no other option. Now, while we're talking about the fast track port, one of the handy features available for PowerBox users is if you hook up a GPS to the same fast track port, the software inside these units allows you to have a feature where the iGyro sensitivity can be reduced as the speed of the aircraft increases. So it's basically a speed or gyro compensation feature in relation to the speed of your aircraft. So let's have a look. We've got our iGyro, our GPS3 here. And there's also another sensor which is common on certain aircraft, particularly larger aircraft, called a true airspeed vario. So a lot of glide pilots use it, jet pilots as well. So that's basically an airspeed sensor using pitot tubes. However, you can also use a GPS sensor, which sort of gives you ground speed instead of true airspeed. A GPS works reasonably well for most instances. And yeah, you'd hook both of these sensors up to the fast track port in conjunction with the iGyro. So the speed compensation, how does it work? Well, basically, as you know, with most aircraft, you can set your gyro gain via your transmitter. If you then go for a fly, you might set your gyro gain to a certain value, but then you'll notice as the aircraft speed increases, and if the aircraft itself has a wide dynamic range as far as airspeed is concerned for the airframe, you might find at 300 or 400 kilometers an hour, you find your gyro gain's way too much, so you have to knock it back, otherwise you get oscillation of your flight surfaces. So the software inside these units allows you to automatically reduce the gyro gain as the velocity of the airframe increases. And there's an airspeed factor that you can have a bit of a fiddle with. You can adjust that. And once it's set, basically what happens is you'll set your gyro gain, say, to a maximum value, which might be, say, when you're coming in for landing or when the aircraft's at very slow speed. You can whack the gain up pretty high. However, as the aircraft starts to increase in speed, the unit itself, whether it's a Mercury or a competition, This feature is also available on standalone receivers as well. In conjunction with the airspeed factor, it'll reduce the gyro gain. So as the aircraft goes faster and faster, the gyro gain drops in value. And that's handy because it's one less thing to worry about insofar as pilot load when you're manipulating switches and that on your transmitter. So it's like an automatic gyro gain, if you like, in relation to the velocity of the aircraft. Little handy feature. Now, you'll notice I've got a little asterisk here for the GPS-3 and the true airspeed vario sensor. And that's because some people get confused, and what they do is they then connect this, say, GPS to one of the telemetry lines. So you've got to remember, when you're using it on a PowerBox system, these two lines become a P2 bus connection that feeds into the receiver. And I've got some receivers here. Let's have a mock-up of a receiver connection. I might have two 26Ds here, and we connect them straight to the RX1 and RX2 lines. That's fine. These lines now basically handle P2 bus data. And as you're aware, or should be aware for PowerBox, the P2 bus is the main telemetry bus. So, a GPS being a telemetry sensor, if we use a Y lead and connect it into here as well, so I could just use a standard Y lead connection, just like that. We could hook up the GPS and one of these receivers. What happens now is the data from the GPS does not go into the Mercury. You can see it on your transmitter screen because the telemetry or the information from the GPS comes out of here, goes into the P2 bus line, but then goes out the receiver to your transmitter. So if the GPS is connected here, you still see things like your velocity, long lat, all that sort of stuff, number of satellites. However, it has no impact on the Mercury. The data is not processed by the Mercury if we connect the GPS to either RX1 or RX2. You must connect it to the fast track line up here. And again, if you want to connect the iGyrosat and GPS together, all you need is a simple Y lead straight into the fast track port. Simple as that. Okay, hopefully that explains the GPS connection, so people shouldn't get confused with that anymore. Now, moving on to the receivers. I'll just remove the gyro out of the way. The receivers, another area where some people get confused. Now remember, I said something about having a little asterisk here on RX1. A very important point to remember is that the telemetry from the Mercury, so any telemetry generated by the Mercury, and that might include things like your battery capacity, things like battery voltage, etc., gyro status. If you got the GPS connected to the fast track, you can get some GPS information as well. That all appears only on the RX1 connection. It does not appear on RX2. So some people make the mistake where they might connect just one receiver to the unit, like this. The unit functions fine, however you won't get any telemetry out of the Mercury because there is no telemetry from the Mercury to the receiver along this line. The telemetry from the Mercury only appears on RX1. So you must connect the receiver to the RX1 connection. Hopefully that makes sense. Some people get caught out with this, especially with Futaba. So just to show you something with Futaba, I'll get my Futaba receiver here, we'll put it here. So you bind this Futaba receiver on the RX1 line, it can receive telemetry, you can see that in your transmitter, no problem. What usually happens is people get carried away, they hook up two receivers. Now with Futaba, unfortunately their system can only support telemetry on one receiver. So if you're using a dual receiver setup with Futaba, it only works off the primary receiver. So when you bind these receivers in your Futaba transmitter, they have a dual mode. So you have like a primary receiver and a secondary receiver in dual mode. And only the primary receiver that's set on the transmitter screen will receive telemetry. So if you accidentally make this one primary, if you bind this one first and this one becomes your primary receiver, and you happen to connect it to the RX2 line, what happens is, again, no telemetry from the Mercury along here. So on your transmitter, it looks like it doesn't work. There's a problem. However, the only problem is that this one's primary and not secondary. So you must ensure that whichever receiver is bound first as the primary receiver is connected to RX1, because the telemetry Mercury, or the Mercury's telemetry, only appears on the RX1 line. You have to remember that if you have any other sensors attached to this telemetry line, it doesn't go back into the Mercury, it basically goes straight to the receiver. So for instance, I could, in theory, hook up my GPS, my PowerBox GPS here, and it'll work with a Futaba receiver, and it'll spit data out to the receiver, and that's fine. However, that data from the GPS won't get processed by the Mercury as such. Okay, so that explains the Futaba setup. A lot of people get that wrong, just something to be aware of. Now going back to the PowerBox. In my second video, I'm going to concentrate a little bit on connecting multiple receivers to the unit, as well as using a satellite receiver, how we configure that. And so in effect, we can have quite a few receivers connected to this unit. One thing a lot of people that are non-PowerBox users seem to forget is the receivers like the 26D. So any of the receivers that have a D on the end of their name, and that includes things like, or receivers like the PBR 9D. So this is just a 9-channel PWM receiver, whereas the 26D is just a straight bus receiver, if you like. So the 9D also has a D on the end of its name, so that indicates it's a dual receiver unit. And by what I mean by that is the actual device inside here, or the circuit boards inside here, feature two separate individual receiver circuits. So there's two separate receive preamps, two separate receivers, basically two individual receivers. In comparison, if we look at the Futaba receiver again, so it looks very similar. We've got two antennas, both units have got two antennas. However, internally they function a lot different than what you'd think they do. So for Futaba, what they do is they only feature one receiver in this unit. And what they do is they quickly switch between the two antennas. So if they lose signal on one antenna, or if it goes poor quality, they'll quickly switch to the secondary antenna. So one receiver switching between the two antennas. In contrast with PowerBox, they have two individual receivers. And when you actually connect this to your radio, you can actually look in the telemetry and you can see that there's two RSSI values, there's two link quality values, totally independent of each other. So just having one receiver like this connected to the Mercury is akin to having two physical separate receivers, basically. If we then connect another one up on the RX2 line, realistically we now have four individual receivers connected to the PowerBox Mercury SR2. So just something to be aware of. And like I said, I'll explain the connections of receivers and that in the next video, because I want to introduce like the satellite receivers and show you how to connect these up. Basically you can add satellites to these, so you can, if you've got a larger aircraft and you want the maximum number of receivers, how do you do it? Well, you can just quickly hook up a single satellite to this particular receiver and another one for this receiver. So in effect, you'll have a total of 6 receivers, and those satellites can be placed anywhere in your aircraft because they're pretty small. Okay, I think that's about it for this video. Like I said, this is only a quick introduction, and we'll move into looking at the full receiver connections in the next video. I'll delve into hooking up multiple telemetry sensors, for instance, because people get confused with that. So probably the first 2 videos are like introductory videos for these sort of products. And also remember, it's not just for the Mercury, it also applies to the competition SR2 and the Royal SR2, because effectively they've got exactly the same connections here. No real difference there. The main difference is they support more PWM ports, and on the Royal you have the bus inputs, which are not physically on this unit obviously, but you've got extra 4 serial bus inputs that are supported on the Royal for fairly large aircraft installations. Okay, thanks all for watching, and I'll catch you soon in the next video. Thank you all.